Okay, so we've already done scientific notation with positive powers of 10. We're gonna now go ahead and do it with our negative powers of 10. So what is a negative power of 10? Okay, so these are values that are in between 0 and 1, such as 10 to the negative first power. This is actually just equal to 1 over 10. So negative powers are essentially just fractions, okay? So this means 1/10. And over here, 10 to the negative 2 power is going to be 1 over 10 times 10, which is going to be equal to 1 over 100. Okay? So you still get those two zeros, except it's in fraction form. You still get that 1 0, except it's in fraction form. Let's go ahead and do a couple more. Negative 3 is going to be 1 times 10 times 10 times 10, which is going to be 1 1,000ths over here. Okay? Now, let's go ahead and look at our final one. It's going to keep following the same pattern. So 10 times 10 times 10 times 10 is going to be equal to 1 over 10,000. Okay, so how do we say this number? 1/10, 100th, 1,000ths, 1/10,000ths. Okay, now let me go ahead and write this in black. Here is what the decimal value actually looks like. This is going to be 0.1. This is going to be 0.01, 0.001, and then 0.0001. As you can see, 4 decimal places, 1, 2, 3, 4. 3 decimal places, 1, 2, 3. Okay, so just keep that in mind as we go over the rest of these problems. Okay, now let's say, why are we doing this? Let's say we have the average diameter of a red blood cell, okay? So that's gonna be about 0.000007 meters, okay? So instead of writing this all the time, all right, 0.000007 meters, we could just go ahead and write it in scientific notation. So this is how it looks. We're gonna take our first number, put a decimal point right after it, and since there are no other numbers here, I'm going to go ahead and write a 0. So we're going to multiply that by 10 to the negative something power. Since this is a decimal, it is a value between 0 and 1, so it's going to have a negative exponent, meaning it's a fraction. Okay? So let's see how much we have to move from this decimal point here all the way to our original. It's going to be 1, 2, 3, 4, 5, 6, 7. So this is 7 times 10 to the negative 7 power, okay? So this is how we would go between our standard decimal notation and our scientific notation. If we were to multiply these numbers out, okay, we would actually be able to get back to our original answer, which is the whole point of scientific notation. So let's go ahead and look at a couple of other examples. Let's say we have 0.00745. And I'm going to go ahead and write this in scientific notation. So first, it's going to be 7.45. My decimal point is going to be here, okay? And I'm going to multiply this by 10 to the negative something power. So I'm going to go ahead and move it to the original decimal place, 1, 2, 3. So it's going to be 7.45 times 10 to the negative third power, okay? Now, mathematically, all this means is that I'm going to take 7.45 and I'm going to multiply it by 1 over, I know that negative 1/3 means thousandths, so 1 over 1,000. And if I go ahead and multiply that out, I'm going to get this number right here, okay? Let's look at another example. Let's say we have 6.75 multiplied by 10 to the negative 5th power. I'm going to go ahead and start with my numbers, 6.75. I know that this is negative, so I'm going to have to go to the left side. So this is going to go 1, 2, 3, 4, and 5. Okay? So I'm going to go ahead and fill in, and then just rewrite the number so I can see it a little bit clearer. So 0.1234, negative 5, and then 7.5. This would be my final answer. And that's how we go from scientific notation with negative powers of 10 into our standard notation or decimal notation.